You've probably heard it in science class or seen it in a textbook. Jupiter is about 484 million miles, or 778 million kilometers, from the Sun. It's a nice, simple number. Easy to remember. But what if I told you that number, while useful, isn't the whole story? That it's a convenient simplification that hides a much deeper and more spectacular truth. A truth about how Jupiter's immense gravity shapes the entire solar system. That one, simple, not quite right number is the key. Because the real story of Jupiter's orbit isn't about a static distance. It's a story of a celestial dance that dictates the architecture of our cosmic home and reveals that our Sun isn't the immovable center of the universe we often imagine it to be. The solar system is not what you think it is, and it all starts with this one orbital oversimplification. The simple number we all learn. Let's start with the number itself. When we ask, how far is Jupiter from the Sun? We get that clean answer, about 484 million miles. In astronomical terms, that's 5.2 astronomical units, meaning it's a little over 5 times farther from the Sun than Earth is. It's a useful number for getting a general sense of scale, a mental map of our solar system with the Sun at the center and the planets laid out in neat, predictable paths. We imagine these paths as perfect circles, like grooves on a record, with each planet sticking to its track. But the universe is rarely that simple. No planet in our solar system travels in a perfect circle. Every single orbit is an ellipse, a slightly stretched out, oval-shaped path. This means a planet's distance from the Sun is constantly changing. For Jupiter, this isn't a minor detail. At its closest approach to the Sun, a point called perihelion, Jupiter is about 460 million miles away. But at its farthest point, aphelion, it drifts out to nearly 507 million miles away. That's a difference of 47 million miles. To put that in perspective, that variation alone is about half the entire distance between the Earth and the Sun. So, to give Jupiter a single, fixed distance isn't just a simplification, it's technically never correct. The planet is in a constant state of moving nearer and farther, a slow, cosmic breath that takes nearly 12 Earth years to complete one cycle. But this is only the first layer of the story. The most profound secret is not just that the distance changes, but what Jupiter is actually orbiting. The real center of the solar system. Here's a fun fact: we're taught that planets orbit the Sun, but that's not quite the whole truth. In reality, any two objects in space, a planet and a star, for instance, orbit their shared center of mass. This invisible point is called the Barycenter. Think of two people on a seesaw. If they weigh the same, the balancing point is right in the middle. But if one person is much heavier, the balancing point has to move much closer to them. The Sun is incredibly massive, about 1,000 times more massive than Jupiter. For a small planet like Earth, our shared Barycenter is deep inside the Sun itself, so it really does look like we're just orbiting the Sun's center. But Jupiter is a monster. It's so massive that it's more than twice as massive as all the other planets in the solar system combined. Because of this immense mass, the Barycenter between the Sun and Jupiter isn't inside the Sun, at least, not always. On average, it's a point in empty space just above the Sun's surface. Let that sink in. It's more accurate to say that Jupiter and the Sun orbit this shared point in space. And because Jupiter's own orbit is an ellipse, the location of this Barycenter moves. Sometimes it's just outside the Sun, and sometimes it dips back inside. This means our Sun, the star that holds the solar system together, is constantly being pulled around in a complex wobble. While Jupiter is the biggest influence, all the giant planets, especially Saturn, contribute to this solar dance. The image of a static, unmoving Sun is an illusion. Our solar system is a dynamic, pulsating system of bodies all tugging on each other, and Jupiter's tug is so powerful it forces the Sun itself to dance. And if the fact that our Sun literally wobbles through space is blowing your mind, you need to stick around. Because this isn't just a cool piece of trivia. This gravitational dance is the reason Jupiter has such a profound influence on the rest of the solar system, and why life on Earth was able to flourish in the first place. Jupiter, architect, and wrecker this gravitational dominance, this ability to pull the Sun itself off center, is the source of Jupiter's power. It isn't just a passive giant, it is one of the system's primary architects. Its influence began early in the solar system's history. The region between Mars and Jupiter is now home to the asteroid belt. Early on, there was likely enough material there to form another planet, but it never happened. Why? Jupiter. As a young Jupiter settled into its orbit, its immense gravity stirred up this region violently. It acted like a gravitational bully, flinging material around and causing planetesimals to smash into each other instead of gently clumping together. It prevented a planet from ever forming, leaving behind the shattered remnants we now call the asteroid belt. Today, its gravity continues to sculpt this belt, creating gaps and shaping the orbits of the asteroids within it. This has led to Jupiter's reputation as our cosmic bodyguard. And it's true that Jupiter's gravity can deflect comets and asteroids, either sucking them in, like comet Shoemaker-Levy 9 in 1994, or flinging them out of the solar system entirely. But the truth is more complicated. Recent studies and simulations show that Jupiter's role is a double-edged sword. While it shields us from some threats, its powerful gravity can also nudge asteroids out of the otherwise stable asteroid belt and send them hurtling toward the inner solar system. So is it a protector or a menace? The answer seems to be both. It's an indifferent force of nature whose gravitational decrees shape the solar system through both creation and destruction. It manages the chaos, and in doing so, it helped create the conditions that made our world possible. A new picture of the solar system, so let's go back to that number, 484 million miles. It's not a lie, it's a lie of simplicity. We use it because the full truth is almost too vast to fit into a neat sentence. The truth is that Jupiter is on a perpetual journey, swinging millions of miles closer and farther from the Sun. And more profoundly, the truth is that it doesn't orbit the Sun's center directly, but instead dances with it around a shifting point in space that it often pulls outside the Sun itself. This single fact reframes our entire understanding of the solar system. It transforms it from a simple, clockwork model into a living, interconnected system. It shows us that gravity isn't a one-way street from the Sun outward, but a complex web of interactions where every object plays a part. The lie of Jupiter's distance isn't malicious, it's a doorway. Once you step through it, you see that the orbital path of one planet is directly tied to the formation of asteroid belts and the long-term safety of our own world. The elegant dance between Jupiter and the Sun is an engine that drives the grand architecture of our solar system. The universe is rarely as simple as we'd like it to be. The neat numbers and perfect circles we use are just convenient placeholders for a reality that is far more chaotic, dynamic, and beautiful. The average distance of Jupiter is a perfect example. It's a number that's useful for textbooks but hides the secret of Jupiter's immense power. It hides a story of a waltzing star and a planet so massive it acts as both an architect and a wrecker for its cosmic neighborhood. Jupiter's true orbit isn't just a path through space, it's a physical force that helps govern our solar system, a gravitational decree that allows a small, blue world like ours to exist. So, the next time you look up and spot the bright, unwavering light of Jupiter, remember what you're really seeing. You're not just looking at a planet. You're looking at the heavyweight champion of our solar system, whose eternal dance with our Sun keeps the entire system in check. If discovering that our Sun wobbles through space changed how you see the solar system, hit that subscribe button. Because if a simple distance can hide a secret this big, imagine what other truths are waiting to be uncovered. Let me know in the comments what other space fact you want to see unpacked next.